substances. So oil is incredibly energy dense. And to give an easy example, think of a Hummer. So everyone always complains that a Hummer is such a bad, evil machine because it only generates 10 miles a gallon, excuse me. And how dare anyone have such an inefficient machine? But think about how efficient oil is for being able to move a 6,000-pound behemoth 10 miles with just one little gallon. I mean, can you do that with drinking a gallon of milk? It's pretty remarkable how much energy is in there that it can move a Hummer 10 miles. And that's an indication of how concentrated the energy in oil is. So that's one thing. So if you're going to power jet planes, if you're going to power cars, if you're going to power machinery, you need a concentrated source of power. Otherwise, what's going to happen is you're going to be completely weighed down. So for instance, something like batteries have certain usefulness in transportation, but if you try to put a battery in a plane, the plane is going to crash because it's too heavy. It doesn't have the energy density of oil. So that's one. That's energy density. So let's look at solar, wind, biofuels. Actually, let's go through. Strike that. We're going to go through those just so we get clear on the whole package. So we've got energy density, and reliability means the ability to have guaranteed controllable flows of energy. So for both portable energy and static energy, it's imperative that we be able to get energy when we need it in the quantity we need it. It's not enough to just kind of get random bursts of electricity in your life. I mean, imagine even watching TV and you don't know if you're going to get electricity or not, right? I mean, I don't know what's on tonight. Like, The Office is on tonight, so you guys are skipping that. Thank you. Hopefully you taped it. But, right, I mean, imagine watching The Office and electricity is just coming sporadically and it's cutting out all the time. I mean, it's an outage. That's a bad thing. But the reason you're not worried about that is because the sources of electricity, it's not usually oil, it's usually coal or natural gas, is reliable. The same thing with your car. Your car's not always stopping all the time. And if it is stopping, it's because of a mechanical failure. It's not a power failure ever in your car. And that's because it's providing a reliable source of energy. So our whole civilization relies on controllable flows of energy. And if you don't have that, imagine your parent is on a respirator and they don't have controllable energy. That's how important it is. And the final one, and the most neglected one, is scalability. There are 850 million oil vehicles in the world. So if something is going to substitute for oil, there has to be an enormously abundant amount of that material. And there's an enormous amount of abundance of oil, and as I'll talk about, there are non-green substitutes that can serve to even increase that abundance further for hundreds and hundreds of years. So let's look at these technologies in the context of these three criteria. So energy density, reliability, and scalability. So let's take biofuels. Biofuels are fuels generated from the carbohydrates in various plants, sometimes manure. So we have the classic, let's look at the three things. Energy density. In general, biofuels are very non-energy dense. So if you take corn ethanol, for example, you take a cornfield, the energy in those ears of corn is much more spread out, both physically between the ears of corn, which needs some distance, but also within an ear of corn, it has nowhere near the energy density of a barrel of oil. And therefore, the processing costs of getting the energy out of that corn are much greater. And even more important, the land costs of that oil are much greater. So we had, when President Bush and others in Congress really strongly pushed the country onto corn ethanol, now they're a little bit, they don't endorse it quite as strongly now, but a couple years ago they were all completely on board, I believe including Barack Obama. They diverted a huge amount of American cropland to the production of corn. It took enormous amounts of corn, and it replaced less than 3% of our oil usage because it is so non-energy dense. And to compound that, the actual fuel you get, so ethanol fuel, is only about 2/3 the energy density of regular gasoline fuel. So that's one, that's energy density. But it gets even worse. Reliability. Well, think about how farmers have reliability problems. Sometimes they have good years, sometimes they have bad years. Well, for that to, if we have an agricultural-based economy, if we get our agriculture from energy, that means that we're dependent on the seasons and the growing seasons for whether we have enough energy or not. And then finally, scalability is the complete deal breaker for biofuels for reasons that have to do with the energy density. When you try to scale it up, what you're scaling it up into, what your competition is fertile cropland. And therefore, the more you scale these technologies up, the more cropland you divert, the more expensive you make the most basic human value, which is food. And therefore, that's why the U.S. got widely condemned for its ethanol policy, because it got accused of driving up food prices for people around the world, which especially hit the poorer people. If you just think about, you're proud of your ethanol SUV, I'm about to make you less proud. Every tank load of just one load in an SUV of corn is enough to feed a person for a year. So this is the kind of diversion that we're talking about. Now, biofuels are pretty bad. Solar and wind actually managed to outdo them in being ineffective. So energy density. Solar and wind, no, they are taking advantage of things that are quote-unquote free. So the sun and the wind. That's the good part of the story. The other good part of the story is that there's an enormous amount of power in the world generated by the sun, an enormous amount of power generated by the wind. The bad part of the story is that power is extremely, extremely dispersed, so that it is very diffuse. So in general, if you put solar panels on a house, it'll generate approximately enough energy to provide what to your house? Guess what? Light, right? Which is pretty much what's coming down. So it's, you can light about as many light bulbs as the sun would provide you. So usually, even when people are putting light bulbs on their house, solar panels on their house, it's generating maybe 9% of their electricity. So to have any kind of chance of any solar installation producing any significant amount of power, it needs to be huge. It needs to take up massive, massive areas of land. Now, as far as reliability, wind is the same thing. Wind and solar have very similar attributes. So wind is also not very energy dense. So you have to have enormous fields and diversions of land for wind turbines. But reliability is really the deal breaker with solar and wind. Because with sun, it's only shining about half the day, and even then you don't know how much is going to shine. So again, imagine that your relative's livelihood depends on whether there are clouds or not. That's the kind of reliability we're talking about. With a wind turbine, the amount of reliable energy you can get from a wind turbine, any given wind turbine, is zero. Just think about any time the wind stops blowing, then the wind turbine isn't working. Now, people say we can build a quote-unquote smart grid to get rid of this problem. It's called the intermittency problem, where you coordinate in some elaborate, computerized network where the sun isn't shining here, so you get it to shine here. Well, you still have the problem of night, and the wind isn't blowing here, but it's blowing here. But the bottom line is that in the aggregate, wind and solar are not constant at all. So there is no reliable, controllable source of electricity. And this is why you will not find a country that generates more than 10% of its electricity from solar and wind. What they can do for show is they can add a couple of windmills and solar panels to their grid without causing too much havoc, because they have what's called baseload power. They have guaranteed power from coal or natural gas. But not once in the history of the world, after 30 years of green Europeans and green Americans trying to get rid of coal and trying to replace it with solar and windmills, not one coal plant has ever been displaced by solar or wind power. And a lot of it has to do with, a huge amount has to do with the reliability factor. And the places where they have the most, such as Germany, power is the most unreliable and they're most prone to blackouts. And finally, related to these is scalability. You can't scale it because it's not reliable, and you can't scale it because it's so incredibly expensive, which again, I want to stress, the proof is in that there is no